Okay, here we come with exercise questions. This is exercise electricity chapter 8, class 10. This is for class 10, and this is exercise question electricity chapter number 8, science. It is for Manipur board student. Okay, it is only for Manipur board students. So this is your exercise question. So let me try solving it. It has been asked, I think one of the student has asked me to solve this. Asked me, sir, please help us in exercise questions. So I am helping that person. If you have any doubts, anything regarding your doubts, anything you have things to ask regarding subject, any problem, you can just ask me here in the comment below, or you can go to channel called GPS Manipur. It is a telegram channel. You can telegram me at just write on t.me/gps Manipur. You go here and you can just join the channel and ask me the questions. Okay, so let's start the chapter. Let us, before understanding, before going through the questions, I have around 30 questions. Before going through all the questions, let us try understanding the formulas. Okay, what are the formulas that we are going to understand here? Formula that we are going to use here? The first formula that we are going to use is, let me add a page so that it will be easy for us to calculate. Okay, the first one is about charge. Charge which is represented by Q will be equal to Ne. What is N? N is number of electrons. And what is E? Charge on each electrons. Charge on each electron. Okay. E is equal to 1.6 into 10 to the power minus 19 coulomb. Okay. This is charged by one electron. One electron. Okay. One electron will have this much charge. Okay. The first formula. Second formula that we are going to use is about current. Current is equal to charge by time. Q is charge here, and T is time here, and I is current. Okay. Then we are going to use the third formula, that is V equal to IR. This is from Ohm's law. Okay. Ohm's law. V is voltage, I is current, R is resistance. All this formula you have to remember. Okay, if you want me to make you understand what are all these formulas are, from where it comes, what does it mean, you can write down in the comment below. I'll be happy to answer that. Okay, but now I need to do only numerical, so let us do the formulas only. This is the third formula. Another formula we may be using, V is equal to work done by charge. This is another formula. W is, this is work done, and Q is charge, and V is voltage. Another formula that we may use is heat is equal to I square RT. Joule's law of heating. This is from Joule's law of heating. So I is current, R is resistance, T is time, and H is heat. There are more formulas like resistors in series will be R equivalent, total resistors will be equal to R1 plus R2 plus dot dot how much R you have, and resistors in parallel will be 1 by Req equal to 1 by R1 plus 1 by R2 and so on. Okay, and there are more formulas that we are going to discuss, that is number 7. Formula number 8 that we may use in this chapter is P is equal to VI. Power is equal to voltage into current. This is power is equal to voltage, and this is current. Okay. Also, we may use formula for energy, which will be voltage into current into time. Okay, VIT. So I hope only these are the formulas that we have. I have summarized all the formulas here. Charge, current, you can see here, charge, current, Ohm's law, power, work or energy, resistance, series, parallel. Okay, so fine, let's go next. These are the formulas. Now let's start the question. Let's start with the first question, question number 1. Okay, this is question number 1. It is from page number 171. This is exercise question. Okay, this is exercise question. So let's start. Let's see, question is 3 into 10 to the power 7 electrons. So 3 to the power 10 to the power 17 electrons. Okay, 30 seconds through an area. What is the electric current? Okay, this is the question. Now before solving, okay, what are the things you need to do? There are 3 steps of solving an equation. First is what is given. What is given in the question? Second is what are the formulas you are going to use. Formulas you will use. And the third is calculation. Okay, we'll follow these 3 steps always. So here in this question, what are the things given? First is 3 into 10 to the power 17 electrons. So what is this? This is number of electrons. 3 into 10 to the power 17 is number of electrons. Second, it cross in 30 seconds. So what is 30 seconds? It is time. Time is 30 seconds. So what is the electric current? So they are giving us N, they are giving us T, and they are asking us to find out current. Okay, so we don't have any formula. What are the formulas we have around current? One is I is equal to Q by T. We have only one formula for current regarding charge and time. Another formula also there, V is equal to IR. So I is equal to V by R. But here voltage also, resistance also, nothing is given in the question. So what we'll do is we'll use this formula, I is equal to Q by T. I equal to Q by T. But okay, T is given. T is 30 seconds. Can you see 30 seconds here? But what is Q? Q we do not know. What is Q? So we can find out Q. What is the formula for Q? Q formula is N. Okay. What is N? N is given in the question. E we know E. E is always 1.6 into 10 to the power minus 19 coulomb. This is fixed for E. So first what you will do is we will use 2 formulae in these questions. One is I is equal to Q by T, and another is to find out the value of Q. We'll use another formula called Q is equal to NE. So what will be the total charge? First let's find out Q. So Q will be equal to NE. What is N? N is 3 into 10 to the power 17 given in the question. What is E? 1.6 into 10 to the power minus 19. If you multiply these two, you will get 4.8 into 10 to the power minus 2 coulomb. Okay. Now current is, now we found out what is the formula for current. Current is equal to charge by time, right? We find out this one using Ne. Okay, we found out Q is equal to Ne. Now we know what is Q. Q is 4.8 into 10 to the power minus 2. Now I will be equal to 4.8 into 10 to the power minus 2 divided by T. T is 30 seconds. So look here, divided by 30, and if I divide this by 30, I will get 4.8, 1.6 into 10 to the power minus 3. I hope you know how to divide and all those things. Please do. Okay, this is a very like a very fast video, so I hope that you don't expect much from me that doing all the calculation. If you find any difficulty, please write down in the comment below. I'll help you there. Don't worry, I'll make the video helping you where is there a doubt. Let's go question number 2. This is question number 2. What is the question asking us? The potential at a point. What is potential? Potential is actually about voltage. Potential and voltage are same thing. At a point is 20 volt. Calculate the amount of work done to bring a charge of 0.5 coulomb from infinity to this point. Okay, so given, what is given? Given is potential, right? Voltage 20 volt and charge is given. What they are asking us? They are asking us to find out work done. So we need to find out work done. So what is the formula that has potential, charge and work done? So we know one formula, V is equal to W by Q, work done by charge. Okay, this is the formula. We have discussed this formula. Now in this formula, voltage is given, charge is also given. We need to find out W. So W will be equal to Q, will go here and multiply QV. So W is equal to QV. Now using this formula, W is equal to QV, Q is 0.5 into V is 20. If I multiply this, I'll get 10 and the answer is 10 joule. Okay, let's go next. Question number 3. Question says a potential difference of 20 volt appears across the ends of a resistor. For those who are watching till now, if you think, okay, if you want these notes, I'll provide it in the Telegram channel. So you go to the Telegram channel. I've mentioned the Telegram channel. If possible, I'll put the QR code here in this particular video, and you can join the Telegram channel. And in the Telegram channel, I'll provide these notes, these digital notes you can see here. I'll provide the PDF there. Okay. So please join the Telegram channel if you want these notes. Question number 3. Question number 3 is a potential difference of 20 volt appears across the end of a resistor when 2.5 ampere of current is passed through it. What is the resistance of the resistor? So there are 3 steps. First is given. What is given? Given is potential difference of 20 volt. Voltage is 20 volt. End of the resistor when current is 2.5. Current is 2.5. Pass through it. What is the resistance? So what they are asking? They have V is given, I is given. They are asking us R. So we have something called Ohm's law. And according to Ohm's law says V is equal to IR. And V is given, I is given. We need to find out R. So R will be equal to, I will go this side, it will become V by I. So look here, R is equal to V by I. We'll use this formula. R, V is 20, I is 2.5. If I divide, I'll get 8. What is 8? 8 is ohm. Sorry, I haven't written here. So 8 ohm. Okay, so resistance will be 8 ohm. Let's go next. Question number 4. Question number 4. Question is, how much charge flows through a wire carrying 2.5 ampere of current in 20 minutes? So current is 2.5 ampere and time is 20 minutes. Keep in mind this. Okay. Now let's go. How much charge? So they are asking us Q. So we have this formula. Q is given, I is given, T. Q they are asking us, I given, T given. So we have the formula I is equal to Q by T. Now we need to find out Q. So Q will be equal to, T will go here, it will become I T. So Q is equal to I T. What is given? Given is current. Another, it is given in 20 minutes. Keep in mind, I need to find out minutes into seconds. I always calculate my charge in seconds. So I will convert 20 minutes into seconds. So what shall I do? 20 into 60. 60 seconds. In 1 minute, there are 60 seconds, right? So 20 minutes will be equal to 20 into 60 seconds. So 1200 seconds. Okay. So it is 1200. Got the point? So now let's use the formula. Formula is charge is equal to IT. From where I got I is equal to Q by T from this formula. So I T will go here. So Q is equal to IT. Now from this formula, charge is equal to Q is equal to IT. I is 2.5 into 1200. And if I multiply this, 12, 224, then 30. So okay, it will be 3000 coulomb. Okay. So I can write down 3000 as 3 into 10 cube. And it is this one. Got the point? And I hope this is the correct answer. Let's go next. Next question, question number 5. Let us discuss this question. Question number 5. Question number 5 says a 9 chrome wire has a diameter 1.0 mm and resistivity of 1.0 into 10 to the power minus 6 meter. Calculate the required length of this wire to make the resistance of 14. Okay. So resistance of 14, and I think this is ohm. Resistance of 14 ohm. This is question number 5. So actually hint is given so that you can understand what, for me at least I'm explaining, so I'm not reading the hint. I have written down the hint to understand the question. If you read this PDF carefully, you will easily understand. If you have any difficulty, write down in the comment below. How to get this PDF, I've already told you. Go to the Telegram channel and join Telegram channel GPS Manipur, and in that you'll find out this. Okay. Now question number 5, given. What is given? First, has a diameter. So diameter is given. Second, resistivity is also given. And the third is to make a resistance, or they are giving us the resistance also 14, and this is ohm, 14 ohm. Okay, now what we need to find out, we need to find out L. Okay, we need to find out a length. So we have one formula is R equal to rho L by A. Resistance is given, rho resistivity is given, L we need to find out, this we need to find out. A given or not? No. Diameter is given, area is not given. Okay, so if it say this is a wire, a very long wire, okay, it looks like a pipe, not pipe also, it's like wire, you know, right? Wire is like this. So the wire, if you take only this part, okay, then diameter of this, you know how to draw the diameter of a, I'm taking only, let's say this is a wire and I'm taking only this part. So diameter of this one is given. So I need to find out the area of this. How shall I find out the area? We know the formula, area is equal to pi r square, you know this. Or can I write down this one as pi d by 2 whole square? Can I write down r is equal to d by 2, right? So this is the formula. I need to find out area. If I find out the area using this diameter, then I can put here in my formula and find out L. Fine with this? So let's go. Let's understand this. Using formula R is equal to rho L by A is equal to pi d square by 2. First, let's find out the area. So area is equal to pi d by 2 whole square. D is given by 2. So if I divide 1 by 2, it will be 0.5. This 2 into 0.5 is 1. And same as it is, pi, got the thing. What is pi? You can put pi as 3.14 and multiply with 0.25 into 10 to the power minus 6. And if I multiply these two, okay, I'll get 0.785, okay, into 10 to the power minus 6. So this is my area. Area is always in meter square. Now I have another formula. Formula is R is equal to rho L by A. I need to find out L. So L is equal to A will go this side, it will become RA. Rho will go and divide this side, it will be divided by rho. So L is equal to RA by rho. So it will be R is 14 into 10, 0.785. 14 is resistance, right? 0.785 into 10 to the power 6 is area. And this is my resistivity rho. If I divide all these things, so I'll get something like this, and that will be my 11 meter. Okay, you can just do the calculation, you try. Okay, it's mathematics, you cannot just look the video and understand everything. I hope you understood all these things. If you have any difficulty, look here. If you look into the PDF, I have made the PDF in this way. Then look, equations are in order. So if you have any difficulty, you just mention me the equation. Sir, I have difficulty in equation number 27. Then I'll easily understand. You just mention in the comment below. If you find any difficulty with any equation, you just say, okay, sir, difficulty in equation number 30, difficulty in equation number 31. I'll make a separate video, okay, in next week. Okay, today is date 25. I'll make video next week. Okay, maybe Saturday or Sunday, let me just figure out whenever I'm free. I'll make video explaining all your problems, okay, wherever you have difficulty with. Okay, but here let me make it short so that it won't take much time for you to, like those students who are having only those one the answer to the question, they may not have any problem. Let's go question number 6. Question number 6 is, a copper wire of certain length has a resistance of 10. Resistance is 10 means 10 ohm. Okay, what will be its resistance after stretching to double its length? Interesting question. This question is very interesting. I like this question. Okay, so for always given, what is given? Given resistance is 10. Okay, and okay, first let me understand the question. Let me make you understand the question. Okay, this question is interesting. There is a copper wire. There is a copper wire, and this copper wire has a resistance of 10 ohm. Okay, now this has a length. Let's say the length is not given in the question. let's say the length of this wire is L. Now what I'll do is I'll stretch this wire to double its length. So the length will become double. If this was L, this will become 2L. So what will happen to the resistance if I increase this length? Are you getting the question? There is a wire and it has length L, resistance is 10 ohm. Now I'm making it longer, it is 2L. Now what will be the resistance? So let's say resistance is 10 ohm, original resistance. What will be the new resistance length? It will be 2L1. What is L1? Is the length of the given length, original length of the copper. So let me say L1 is original length. Okay, so new length will be 2L1 double, right? Volume. Okay, so this is little bit complex for you. I don't know whether you can understand or not, but okay. So now what you can understand is you have increased the length, but will the volume change? What is volume? You know volume, right? Volume is equal to length into breadth. Let's say this is my rectangle, it will be easy. This is, let's say, breadth, this is length. Now what you do is you increase the length double, 2L. Now what will happen to the breadth? Breadth will become half, right? If you increase this side, then this side will become smaller. Similarly, so what will be the area here? So length into breadth. What will be the area here? 2L into B by 2. So it will be length into breadth. So volume will not change. You may increase, you may stretch, you may stretch, okay, or you may deform. Whatever you want to do, you can do, but volume remains same. So volume remain constant. Okay. Now let's say volume. What will be the volume? Volume will be, this is my area, right? Let's say this is A1. So this area will be A2. So L1, this is L1. L1 into A1 will be equal to, let's say this one, this 2L, then take it as L2 into A2. So I'm writing like that. V is equal to A1 L1, A2 L2. Okay, we know the formula. R is equal to rho L by A. Now volume, when you stretch the wire, the volume remain constant. So V, A1 L1, A2 L2. So A1 L1 equal to A2. What is L2? L2 is 2L1, right? 2L1. So A2 will be equal to, this one will come this side. So A2 will be equal to A1 L1 divided by 2L1. These two will be cancelled. So A2 will become half of A1. Simple. If you stretch the length, area will decrease. Okay. Now let's find out the new resistance R2, rho L2 by A2. Rho, what is L2? L2 is 2L1. 2L1 divided by, what is A2? A2 is A1 divided by 2. So 2 will go up, it will be rho 2 to the 4 L1 divided by A1. So I can write down as 4 rho L1 by A1. So for this part I can write down as R1. So it is 4R1. What is R1? What is R1? What is R1? Given in the question. What is R1? R1 is given in the question as 10 ohm. So 4 into 10 ohm, which is 40 ohm. I hope you understood this question. Let's go next. If you have any difficulty in any equation is written here, okay? If you have difficulty in any equations, you can ask me. You just mention the equation in the comment. I'll explain you. Don't worry. Let's go next. Question number 7. Question number 7 says, two resistors of resistance 10 and 30 ohm. Why am I not writing ohm in all the questions? Ohms are connected in parallel. A battery supplies a current of 6 ampere to the combination shown in the circuit. So calculate the current in each resistor. Okay, two resistors are there, R1, R2, and connected in parallel. These two are connected in parallel. Okay, so current is 6 ampere. Okay, Calculate the current in each register. So I don't know anything. What I know is, this is a very wrong way to represent. Let me use a remover. And what does the question says? Question says that this 6 ampere current, okay, it is given to these two resistors. These two resistors 10 ohm and 30 ohm are connected in parallel. Sir, parallel can be like this also, right? Yeah, you can draw like this also. Sir, these two are parallel. How much current you are giving? You are giving current of 6 ampere. Through what? You can put a battery also. Sir, without battery, how current will go? Yeah, you can put battery like this and give current. You can go on like this also. Fine. You can put battery and say, I don't know the voltage, but current is 6 ampere. Okay. So 6 ampere current goes to 10 ohm and 30 ohm. So what the question is asking us is, find out the current, find out this current I1 and find out this current I2, current through this. Okay. So first of all, what are the formulas we are going to use? Parallel resistors in parallel formula, 1 by Req is equal to 1 by R1 plus 1 by R2, and we'll use voltage formula, V is equal to IR. Okay. So V is equal to IR. So first is 1 by Req equal to 1 by R1 plus 1 by R2. So what is this? 1 by R1 is 1 by 10, 1 by R2 is 1 by 30. So 1 by 10, 1 by 30, this one, 10 and 30, they are in parallel, right? So how much will I get? We'll get 30, 3, 10, 3 plus 1. So all these things you get calculate, and you got Req is 7.5. Okay. Now let's find out the voltage. Okay. After that, I want to find out the voltage. Voltage is equal to 7.5. What is 7.5? Sir, these two in parallel make 7.5. Got the thing? 7.5 into 6. Why 6? Because this is the current. So now I got, this is 7.5 ohm, current is 6 ampere. Now what will be the voltage here? Voltage will be 7.6 into 7.5 into 6, 45 volt. Okay. Now 45 volt. Now I need to find out the current through each resistor. I got the voltage, right? 45 volt. Now take this voltage, 45 volt. I got 45 volt now. What will be the voltage? Voltage is 45 volt. Now take voltage divided by current. Voltage divided by resistors. 45 divided by 10, 4.5. 45 divided by 30, it will be 1.5. Okay. Similarly like this. So I1 is equal to voltage divided by R1, 4.5. I2, 45 divided by 30, 1.5. So what are the steps that is being followed? You may find it a bit confusion here in this question. It is simple. There are two resistors given, one is 30 ohm, another is 10 ohm, and what is given is there is a battery connected to it. I don't know what is battery, but I know 6 ampere current is flowing through it. First step is, what I'll do is I'll find out the resistance here, equivalent resistance. So equivalent resistance I find out to be 7.5 because these two are connected in parallel. 6 ampere current is passing through this, and there is voltage here. So 6.6 into 7.5, I find out the voltage to be how much? 45 volt. Now this V will be equal to 45. So V is equal to 45. Now V is equal to 45. So what will be the current here? So current here will be I will be equal to voltage by resistance. So voltage is already 45 divided by resistance is 10. Here also 45 divided by 30. Okay. I hope you understood this. I hope you understood this. If you have any difficulty, please do write in the comment below. I'm there. I'll help you. And the most easy for you to ask will be regarding questions. This equation number. You can take this equation number and ask. Okay. Let's go question number 8. What does question number 8 says? You are given three resistors of resistance 1, 2 and 3 ohm. So by diagram, how with the help of these resistors, you can get resistances of 6, 1.5, 2.5, 6 by 11, 11 by 6. The most good way to do this is take this 3 resistor. Okay, the most good way is first you take this 3 resistor, 1, 2, 3. First you connect in, you don't know what is the question. Look, they are asking very different questions, right? First you take these three and connect in series. Okay, when you take these three and connect in series means 3, you will do no 3 means r is equal to r1 plus r2 plus r3. What is r1? 1 plus 2 plus 3, 6. Okay, I got 6. Now is the question asking us anywhere 6? Yes, the first one is 6. So if I connect 3 in resistance, 3 resistor in series, okay, I got 6. Okay, let's go next. Let me connect 3, 1, 2, 3 in parallel. If I connect 3 in parallel, parallel means 1 by Req equal to 1 by R1 plus 1 by R2 plus 1 by R3. What is 1 by R1? 1 by 1. 1 is 1 by R2, R2, 1 by 2, 1 by R3, 1 by 3. If I take this, 3, 2 is 6, 6 plus 3 plus 2, 6, 7, 8, 9, 10, 11 by 6. So I got 11 by 6. Where is 11 by 6? Okay, this one. Okay, if I connect 3 in parallel, I got 11 by 6. So last one is, look, all 3 in parallel, I got 11 by 6. Okay, so 1 by r, 11 by 6. Okay, no, sorry, I got 1 by req is equal to 11 by 6, right? So req will go up, so that means 6 will go up and 11 will come down. So 6 by 11, where is 6 by 11? This one, sorry, it is Roman number 4. So if you go to Roman number 4, you'll find out that, okay, Roman number 4, 6 by 11 I got by connecting all 3 in parallel. Now what, try another combination. Try another combination. What may be the another combination? Sir, I want 1 in series. Let me do 2 and 3 in parallel, like this. So what shall I do? 1 plus these 2 in parallel, right? First you solve these two, it will be easy for you. Solve these two, 2 and 3 in parallel. So 1 by r equal to eq is equal to 1 by 2 plus 1 by 3. So if you solve 1 by req is equal to 2 and 3 LCM, it will be 6, 2, 3, 6, 3, 2, 6. So it is 5 by 6, 1 by req. And so req will be equal to 6 by 5. Check. I got req. This one is 6 by 5. Now 1 is also there. So it will be 1 plus 6 by 5. 1 by 6 plus 5, 5. 6 plus 5 is 11. 11 by 5. Is there anywhere that it is written 11 by 5 or not? Okay, just search for something that it is written 11 by 5. Is there anywhere? No. So not possible. Okay, this combination is not given. Now try another way now. If this is not given, so do like this. Take 3 here, 2 here, 1 here. Take combination like this. Then you'll find, like, look here, 3 is given, 1 is given, 2 is given. If you take these two parallel, then 1 by r we got 3 by 2. And if you take 3 plus this is, if you take r 2 by 3, 3 by 2, 1 by r is equal to 2 by 3, so 2 by 3. If you take this 3, 3, 9 plus 2 by 3, 9, 10, 11 by 3, you get the answer 11 by 3. Got the thing? Got the thing? So if you do like this, so how do we know? You have to do different combination and check. There is no other way. Let me tell you. Okay, let me tell you. Actually, I have written all the answers properly here. Diagram is given properly. Check it out and do. Okay, take different combinations. Sir, what are the other combinations you can have? Yeah, you can have anything. You can take 1, 2 and 3 like this. So 1 and 2, they are in series, so it will be 3. And another is 3. So 3 and 3 parallel, so it will be 1.5. Where is 1.5? Yeah, second one. Yeah, you can check combinations like this. Okay, if you have any difficulty, comment is always there. I'm there to help you. For this question, there are no equations, so you can just mention question number 8, which point you are finding difficulty with. Okay, which are the point that you find difficulty with, you can just tell me and I will be there to explain you. Don't worry. Okay, next week, I promise you, one day next week I'll be solving all the doubts that comes into the comment section of all these videos. Let's go next. Question number 9. What does question number 9 says? Question number 9 says a register of 10 is connected in parallel with another resistor X. The resultant resistance of the combination is found to be 3.75. What is the value of X? So we have 10, okay, and another resistor is X. They are connected in parallel, and the equivalent Req comes out to be 3.75. This is the equivalent one. Okay, now let's go. Req, 1 by Req equal to 10 into X, 1 by 10 plus 1 by X. Okay, we'll use this formula. So look here, 1 Req, what is Req? Req is 3.75. What is R1? 10. R2 X. Okay, now if I calculate, you will take this one this side, it will become minus here. I'm going to find out 1 by X. So take the LCM this side, 3.75 into 10. I hope you know how to calculate. Okay, if you have any difficulty, don't worry, please write down in the comment, don't be afraid, write down in the comment below. Okay, I may explain you in the comment. I'll make video if the question is really genuine. I'm telling you, that's my promise. So if you go on like this, you'll find out the value of X to be 6 ohm. It's very easy question. Please, if you have any difficulty, comment is there. I'm telling you again and again. Let's go question number 10. What does question number 10 says? How many resistors of 200 ohm each are required to parallel combination so as to carry 5 ampere on 200 volt line supply? So how many resistors of 200 ohm each are required in parallel combinations? So I have 200 ohm. I'm going to connect in parallel like this. Okay, I don't know how many, but I'm going to connect in parallel like this. Find the equivalent resistance. Okay, so as to carry 5 ampere, it will carry 5 ampere on how many? 200 volt line. Okay, so very easy question actually. What is given? Resistor, each resistor 200 ohm, current is 5 ampere, voltage is 200 volt. Now what will be the equivalent resistance? So we use V by IR, okay, and find out Req. Req will be V by I. V is 200 volt, I is 5 ampere, 200 by 5, it is 40. I got 40 ohm. Okay, now 40 ohm is the equivalent one. Now I need to make 40 ohm. Okay, then. So another thing I need to understand is, what is the another thing that I need to understand? Another thing I need to understand is 1 by Req equal to 1 by R1 plus 1 by R2 plus dot 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 1 by Rn. There are n resistance, but let's say all these are equal. 1 by R plus R1, R2, R3 all are equal. So I can write 1 by R1, R2, R3, Rn all are equal to R, let's say. Now what will be the LCM of this one? LCM will be R. Sir, 1 plus 1 plus 1 plus dot 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 1. So what will be this? How many resistors are there? Let's say n, it will be n by R. Why a 1 plus 1? Because there are n resistors, right? So it will be n by R. Let's say, sir, we don't have n resistors, we have only 3. Only 3 are there. Let's say only 3. Only 1 by R. Only 3, sir. Only these 3. R, 1 plus 1 plus 1. So 3 by R. Are you getting my point? If there are 3 resistors, it will be 3 by R. If there are 4 resistors, it will be 4 by R. And if there are n resistors, it will be n by R. Okay? This one is clear. Now I know resistance equivalent, which is 40. So this 40, we know another formula, that 1 by Req equal to n by R. Req is given to be 40. We have calculated it. N, we need to find out. R is given to be 200. So n will be equal to 200 will go here, divided by 40. 0, 4, 5 is 20. 5. I'm telling you again and again, please, if you have any difficulty, okay, please do write in the comment below. I'm explaining very roughly. I know that I'm not going very detailedly. So please, if you have any difficulty, please do write in the comment below. Question number 11. What does question says? Suppose there are number of bulbs rated 200 volt, 220 to 100 watt each. How many bulbs can be connected in parallel across 220 volt supply line if the maximum permissible current is 5 ampere only? Suppose there are number of bulb rated. This is the rating of the bulb. So bulb is 100 watt. Okay, voltage is 220 volt. How many bulbs can be connected in parallel across 220 volt? Okay, if the maximum current permissible is only 5 ampere, so I max is maximum current permissible, I max is 5 ampere. We know formula is P is equal to VI. Okay, we know P is equal to VI, right? Now we can do from here I is equal to P by V. So formula is I is equal to P by V. Okay, now I bulb, we know each bulb it will have 100 watt and 220 volt. So 100 watt divided by 220, 0.45 ampere. This is for one bulb, but total current how much can flow? Sir, how much current can flow? Sir, there must be 5 ampere. This much current can flow. Sir, where? In parallel. Okay, so how to do? Look, there are bulb. This is one bulb, another bulb is connected, another bulb is connected, another bulb is connected, like this. Okay, I'll make the diagram, don't worry. In notes you'll find out a proper diagram. This is one bulb, this is another bulb, this is another bulb, like this. There are many bulbs and total current is 5 ampere. This one current I got to be 0.45 ampere. This one is 0.45 ampere. This one is 0.45 ampere. This one 0.45 ampere. Now add all this, it must be 5. So how many bulbs are needed? I need to find out. Simple. So maximum current is equal to N into current in each bulb. So N I max is 5 ampere. N I don't know. One bulb it has 0.45 ampere. So N will be equal to this 0.45 will come this side and divide. If I divide, I'll get 11.11. Look here. So 0.11 it cannot be done that. So there will be 11 bulbs. Okay. Why, sir, 0.11? You cannot have 0.11 bulb, right? You can have one bulb, two bulbs, three bulbs like that, right? You cannot have, sir, I want to buy half bulb. No, you cannot do that. Okay. So I hope you understood this. Let's go next. I'm telling you again and again. If you have any difficulty, please write in the comment below. Sorry, I forgot to write the equations here. Okay. Anyway, you can just tell me the page number, or you can say just okay, sir, in this number, in this time of the video, I didn't understand. Okay. Or this question I didn't understand. I'll tell you. Don't worry. Sorry, I forgot to write the equation. Problem number 12. This is question number 12. Question number 12, we have calculate the energy transferred in kilowatt hours by 5 ampere current flowing through a resistance of 2 ohm for 40 minutes. Okay, here we go. So energy transfer. So what is transfer in kilowatt hours? Kilowatt hours by 5 ampere current. So current is 5 ampere flowing through a resistance of 2 ohm. Time is 40 minutes. Given I is 5 ampere, resistance 2 ohm, time is 40 minutes. 40 minutes, I want you to calculate this in, okay, sir, this 40 minutes I have to convert in second or hour. Sir, energy is in hour, this kilowatt hours. So if hours is here, then you have to convert this into hours. Otherwise second. If nothing is given, it is second. Understand that. But hour is here, na, kilowatt hours. So you convert this into hours. So in order to convert 40 minutes into hour, it will be 40 by 60, 2 by 3 hours. Now formula we know. What the question is asking? Question is asking us to find the energy. So energy is equal to I square RT. I can use this, or I can use VIT. I can use PT. Any formula. So formula is P I square RT. So why I square RT? Why not VIT? Sir, voltage is not given. I and T are given. So I, T, R are given. I, T, R. Look, three things. I, R, T. Three things are given. So what I'll use is which formula? P is equal to I square R. So energy will be power into time. Okay. Or I can directly use energy is equal to I square RT. Okay, sir, this is heat. Yes, heat is also an energy. You know heat, right? This formula is from heat, Joule's law of heating. So P is equal to I square R. I square R, I is 5 square into R is 2. 5 5 25 into 2 50 watt. Okay. Now energy will be power into time. Power time is 2 by 3 mean hour. So if I multiply, I got this 0.33 kilowatt hour. Okay. Sir, kilowatt from where coming? So I square 5 5 25. Okay. 5 5 25 into 2, it is 50 watt. But 50, if I need to write down in kilo means 50 divided by 1000. Okay, then I can write down as 0.05 kilowatt. So why kilowatt? Because the question is asking us to find it kilowatt, not in watt. If it was watt, you don't need to divide by 1000. So multiply by time and I got this. You just check it out, you'll understand, don't worry. Okay, if you don't, I'm telling you again and again, please write in the comment below, or go to my Telegram channel and join and ask me, post me the question there. I'll help you. Let's go next. Problem number 13. An electric bulb is rated 220 200 watt, 220 watt. So this is voltage. This is power. What is the resistance of the filament? So what they're asking is resistance. Okay. Power is equal to I square R. One formula. Another is VI, or I can add on Vi, right? V is given, I is not given. I is not given. So what I can add on? I is, I can add on I is V by R. Yes. V is equal to IR. So I will be equal to R will come this side, V by R. So I'll get V square by R. So this is the power formula for power. There are many formulas for power. Okay. So this is another formula for power. So V square by R. Now V is given, power is given, so R will be equal to V square by power comes this side. So V square is how much? 220 square, power is 200. 220 ka square how much? 48400 divided by 200. I've already calculated and I'll get the answer like this. Just check it out, it's very easy. Okay, let's go with question number 14. What does question number 14 says? Two resistors 10 ohm 20 ohm are connected in series. So 10 ohm and 20 ohm are connected in series across voltage is how much? 12 volt. Calculate the power consumed by each of them. So how much power is consumed here? You have to calculate how much power is consumed here. You have to calculate. Many ways of doing that. But power is, I can use this formula I square R, right? I can use this. So first let me find out I. How to find out I? 12 resistance is given. So 10 plus 20 is 30 ohm is connected across 12 volt. So if I divide 12 divided by 30, it will be how much? 12 divided by 30. 12 divided by 30 how much? 3, 0.4. Right. So 0.4, this is my current. So this current, look now, this is how I'll tell you. Now what is given in the question? Given two resistor 10 ohm 20 ohm R1 and R2 given are connected in series. They are connected in series. Okay, make like this. The longer one you make upside, this one downside. Okay, now they are connected in series across 12 volt. So this is my 12 volt battery. So you can connect battery here also, same thing, but let me make it here what is given, already given. So calculate the power consumed by each of them respectively. So how much power is consumed here, how much power is consumed here? They are connected in series. R total what will be? 10 plus 20. So if I make this one 30 ohm, R plus 20, 30 ohm connected across 12 volt battery. Okay, now current, how much will be the current? Current will be voltage 12 divided by 30. So it is 0.4 ampere. So current is 0.4 ampere. Power consumed by 10 ohm, this is 0.4 ampere. So power consumed by 10 ohm will be I square R1. I square is 0.4 is square into 10, which is 1.6 watt. Power consumed by 20 ohm. This 20 ohm resistor, it will be P2, it will be I square R2 0.4 whole square into R2 is 20, it will be 3.2 watt. Okay, same is very easy. Okay, let's go next. Question number 15. Question number 15 is, if the potential difference between the ends of fixed resistor is doubled, by how much does the electric power change? Okay, resistance is fixed. So if the potential difference between the ends of a fixed resistor is doubled, how much does the electric power change? So resistance is fixed, constant. Potential difference is doubled. So there is a resistor. What does it mean is, let's say this is my battery. This is V. Now what I'll do is I'll double this. Let's say if it is 10, then I'll make it 20. I'll double. Potential is doubled. Okay. Now how much, if I double this voltage, so power, how much power will change? What will be power value here if it is doubled? So formula is V square by R. Why V square by R? Because V is given, resistance is given, V potential is given, resistance V square by R. Power 1 V square by R. Power 2, voltage is doubled, so it will be 2V square by R. 2V is 4 V square by R. 4 V square by R is P1, V square by R. This one is V square by R is P1. So it will be 4 times of the original power. Okay, so you can calculate all these things. It is written in very simple words here. By just reading, you'll understand. If you have any difficulty, I'm telling you again and again, I'm there. Write down in the comment below. Comment is there for you. You can go to the Telegram channel and join and post the video there. Post the photo there. Ask me the question. Tell me which question to solve. I will solve. Don't worry. Let's go next. It's problem number 16. Which one will consume more energy? A 300-watt television set in 1 hour or 1000-watt electric heater in 10 minutes? Which one will consume more energy? So this one, television set in 1 hour, or this one in 10 minutes? Okay, so energy is power into time. So first you calculate power into time. Television power is given, right? So P1 300 watt, time is 1 hour. P2 1000 watt, time is 10 minutes. Minutes you convert into hour, it will be 1 by 6 hour. Formula we know, energy consumed by television will be how much? Power into time, power into time. So it will be 300 watt hour. Whatever energy consumed by electric heater, E2 power time 1000 watt into time, 1000 by 6, it will be 166 watt hour. Which one is more, this one or this one? Obviously this one. So E1 is greater than E2, so television set will consume more energy. Okay, energy depends upon time, so it will consume more energy. I hope you understood this. Let's go next. Next question is question number 17. 17, what does the question says? Question says, state whether an electric heater will consume more or less energy per second when the length of its heating element is reduced. Give an explanation for your answer. State whether an electric heater will consume more or less electrical energy per second when the length of its heating element is reduced. Consider how resistance changes with length using resistance formula. Then okay, leave it. Let us understand whether electric heater will consume more or less electrical energy per second when the length of its heating element is reduced. So length of the heating element is reduced. Let's say this is my heating element. So I'm giving current. Okay, it is producing heat. Okay, now what I'll do is I'll cut this. I'll make it shorter. I'll make it shorter like this. Now I'm giving current here. Now will it produce more energy? Will it produce more heat or not? Voltage is not changed. Voltage is fixed. So R rho L by A. Power is V square by R. When the length is reduced, resistance decreases. R is equal to rho L by A, right? Less length, less resistance. Since P is equal to V by V square by R, that is when R is less, if this denominator is less, power will be more. So this power will increase. So power consumed per second will be equal to energy per second. Look, so when the length of the heating element is reduced, its resistance decreases. If length is less, then R is proportional to 1 by L, right? If length is less, resistance will be more. uh, Resistance is proportional to L. I'm sorry, resistance is proportional to L. R is proportional to L. So if length is reduced, resistance also reduced, and power is equal to V square by R. That is, if resistance is reduced, then power will increase. So when the length of the resistance reduces, its resistance decreases. Since the voltage across the heater remain constant, the power consumed, which is energy per second, increases according to this one. So electric heater will consume more electrical energy per second. So energy consumption will be more. Okay, I hope you understood this. I've written down the explanation in very detail. I didn't think so I miss out any points here. Question number 18, problem number 18. Let's do this. Is it possible to have a particle with charge 2.0 into 10 to the power minus 19 coulomb? Okay, let's check. Is it possible to have this much charge? One electron is equal to 1.6 into 10 to the power minus 19 coulomb. Okay, 1.6 into 10 to the power minus 19 coulomb. So 1.6 and 2.0, which one is more? Sir, 2.0 is more. Obviously, right? 2.0 is more. Now let's check. Charge given is 2.0 and 10 to the power minus 19. How much charge electron this one? We know the formula, Q is equal to Ne. Q is 2.0 into 10 to the power minus 19 coulomb. N, E is how much? 1.6 into 10 to the power minus 19 coulomb. So N will be equal to 22.0 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19 coulomb. So 2.0, this one cancels. 2.0 by 6, 1.6, 1.25. Now N, what is N? N is, I got the value of N to be 1.25. But N means number of electrons, right? Number of electrons. Can there be half electrons? No, I cannot divide electrons, right? So 1.25 is not whole number. This is not a number. N is not, it is not 0, 1, 2 like this. It's not a whole number. So given charge is not a multiple of fundamental charge. This is not whole number, this is a decimal number. It is not possible to have decimal electrons. So according to quantization of charge, any charge must be an integral multiple of the fundamental charge. It is not possible to have particle with this one, therefore not possible. If instead of this one it is 3.2, if I divide this one, I'll get 2 answer. Then it is possible. If in the question they have asked 3.2 into 10 to the power minus 19 coulomb, then the answer is yes, because I'll get the answer to be 2, which is natural number, which is whole number. Are you getting my point? Okay, decimal number is not possible, therefore it is not possible. Let's go next. Question number 19. So a bulb is rated 250 volt, 0.4 ampere. Find its resistance, power. So bulb 250 volt, voltage is equal to 250, 0.4 ampere, current is equal to 0.4 ampere. Find its resistance R and find its power. Okay, voltage is given, current is given. I need to find out resistance and power. Done. Voltage, current, resistance is equal to V by I. Finish. Voltage is given, current, divide, you will find out resistance. Power is equal to V into I, voltage into current. So V by I, V into I. Sir, we have many formula for power. P is equal to I square R, V square by R, Vi. So can I use any formula? Yes, if it is given in the question, use I square R. What is I? 0.4 ampere. 0.4 square into R is how much? R is 625. You get the answer. 0.4 square is 0.16 into 625. If I multiply these two, I'll get 100. 100, yes. I just need to multiply these two. I'll get 100. If not, please check. I may be wrong, but please check. So you can do whatever, any formula you can use and find out. But here why am I using Vi? Because Vi is given in the question is giving us Vi. Okay, so therefore we use this formula. Let's go next. Next is problem number 20. An electric kettle reach 220 volt, 2.2 kilowatt, works for 3 hours. Find the energy consumed and current drawn. An electric kettle is rated at 220 and 2.2 kilowatt, works for 3 hours. So voltage is 220 volt. Power is 2.2 kilowatt, meaning 2.2 into 1000 watt. Works for 3 hours, meaning it is working for 3 hours. So find the energy consumed. So energy is P T. And what else? Current drawn I is equal to V by I, V by R, or V, sir, R is not there, or I can say P is equal to VI, I will be equal to V will go this side, P by V. Use this formula. So energy consumed is equal to P into T. P is 2.2 kilowatt into 3, 6.6 kilowatt hour. And current drawn I is equal to P by V. P is 2200 divided by 220 is the voltage. So you got the answer to be 10 ampere. Okay. Energy consumed you got, current drawn you got. I hope you understood this one. I didn't think so any difficulty is here. If any difficulty is here, comment is there for you. Please do write in the comment below. That's all. Let's go next. Next question is question number 21. Okay, question number 21 is MCQ questions. I think there are around 10 MCQ questions. Let us try doing all this. So the first is a piece of nichrome wire of resistance R is cut into 4 equal parts. Okay, these parts are then combined in parallel. If R is the equivalent resistance of the parallel combination, then the ratio R dash by R will be. It's very easy. What is the original resistance? R given in the question. Now I have cut this into 4 parts. So wire cut into 4 parts. Parts we are combining in parallel. Let's say we are combining in parallel R1, R2, R3 and R4 combined in parallel. So 1 by R dash is combined in parallel like this. This is R1, R divided by 4, R divided by 4, R divided by 4, R divided by 4. When a wire is cut into 4 equal parts, each part has resistance R by 4. Now use 1 R by 4, then you find out 16 by R, finish. Therefore the new resistance R dash will be R by 16. So basically what we do in this question is, you may find it like, oh sir, you are just explaining what is written. So what is actually happening is, you have a wire. Let's say this is a wire. This wire in the beginning it is having R. Now I cut this into 4 parts. For 1 part, 2 part, 3 part, 4 part. There are 1, 2, 3, 4. This is R1, this is R2, this is R3, this is R4. R1 will be R divided by 4, R divided by 4, R divided by 4, R divided by 4. Now I am taking this whole part and connecting it in parallel. I am taking this and I am connecting it in parallel like this, 3, 4. This is R by 4, R by 4, R by 4, R by 4. And I am putting all these equations, look here, in this equation I am putting the value. And when I calculate, I found the answer to be 1 by 16. So the answer is D. Similarly, question number 22. The term does not represent the electrical power. Okay, so from this question, which is not power? This one, not electric power. P is equal to VI power. P is equal to, instead of V, I can write down IR. I into I square R power. Or I can write down P is equal to I VI. Instead of I can write down V by R. So I can write down V square by R. So all these are power. V square by R is power, VI is power, I square R is power. This is not power. So B does not represent power. I hope the answer is B. Okay. Next, question number 23. An electric bulb is rated 220 volt, 100 watt. The same is operated at 110 volt. Due to load setting, the actual power consumed will be, what will be the power consumed? Voltage is V1 220, power P1 100 watt. Power operating power voltage is given to be 110 watt, 110 volt. So formula is p equal to v square by r is v square by p. Use this and you'll find out this one. So similarly, you can go on. If you have any difficulty with MCQ questions, you can just ask me which one. I'll provide these notes in the Telegram channel. Okay. And this question number 29. Question number 29 also I have written down the answer. Why is the series arrangement of the component not used for domestic circuits? Explain. I've explained it very in step by step, okay, like numerical type. So series circuits properties, same current flows, voltage divides. Series arrangement is not used for domestic circuit because voltage division can, all these things I've written down. Please read, you'll understand. I don't want to make the video very long, okay, because you will not watch. So that's why I make the video very short. If you are interested, I'm telling you again and again, please, if you find any difficulty, there is comment, you can write down in the comment below. In this page, in this PDF, I have provided the question from exercise. It is page number 171 to 173. All the question number 1 to question number 30. And this PDF I'll provide in the Telegram link. Those who join the Telegram, you'll find the video, you'll find the PDF. If you don't join, I'm sorry, I don't know where. Sir, which Telegram channel? That is in Telegram, you can go GPS Manipur. Uh, exactly what you can write down is t.me. I think it is t.me. Yes, t.me/GPS Manipur. You can write down this, okay, GPS Manipur, and you'll find out the link there. If I'll provide the QR code scanner, okay, so that it will be easy. You can just scan the code and join. Okay, that's all. Thank you so much.